Randhawa and I'm an electrical engineer graduated from Thapar University, Patiala in 2009. I've been teaching mathematics to students since 10 years now. Hello friends, today we are going to study inverse trigonometric functions. Well, many a times question comes into students' minds that who studies inverse trigonometry? Like, why are we studying it for? There are no practical implications of inverse trigonometry, right? So, alright, imagine on a winter afternoon, you are sitting on your couch and the sun's rays are directly entering into your living room, right onto the couch you are sitting on, making the whole atmosphere very comfortable for you. So this imagination can be turned into reality only and only when the person designing your home is having the knowledge of inverse trigonometry. Yes, that's right. That is because all the complex calculations that goes into calculating the angle onto which the sun's rays will enter into your living room requires the knowledge of inverse trigonometric functions. So today we are going to study a very interesting proof of inverse trigonometry, which not only will help in your school examinations directly, but also will give you insights as to how to approach difficult problems of inverse trigonometry. So let us start with the proof of inverse trigonometry. Now this proof is a very important one. It says if x is less than 0, y is less than 0 and x into y is greater than 1, then prove that tan inverse x plus tan inverse y is equal to minus pi plus tan inverse x plus y upon 1 minus xy. So let us start the proof. We should always start the proof by let tan inverse x is equal to a. So this implies x is equal to tan a. Again, let tan inverse y is equal to b. Then this implies y is equal to tan b. Let us name it as 1. Now, we already know that a comma b is an angle which lies between minus pi by 2 to pi by 2, because that is the range of tan inverse functions. Now let us start analyzing it a little more. Tan of a plus b, students, is nothing but tan a plus tan b upon 1 minus tan a tan b. And yes, we recall it very well because right now we have studied that tan a is nothing but x in this proof of ours and tan b is nothing but y in this proof of ours. So we will name our third observation as x plus y upon 1 minus xy as tan of a plus b. Now, according to my given conditions, this ratio x plus y upon 1 minus xy is clearly positive. Why is that so? Because, as you recall, x is less than 0, y is less than 0. So that makes our numerator go less than 0. As well as x into y is less than 1. So that makes our denominator also less than 0. Hence the whole ratio becomes greater than 0. What does this imply? This implies tan of a plus b is a positive entity, which in turns tell me that a plus b is an angle lying in first quadrant or third quadrant, right? And we are going to make clear note of it. So this is my third observation. This goes as my fourth observation. Let us analyze A and B separately. We know that x is less than 0, so that makes my tan A go negative, students. If tan A is negative, then it has to be the angle of second or fourth quadrant. Very simple observation. But since A belongs to minus pi by 2 to pi by 2, so A clearly belongs to minus pi by 2 to 0. Using my second observation. Similarly, we are knowing that y is negative implies tan of b is negative implies b also belongs to minus pi by 2 to 0. So from these two, I already know that a plus b is an angle which should lie either in first quadrant or in third quadrant. Let us analyze what is a plus b actually, because we are already knowing that a belongs to minus pi by 2 to 0 and b belongs to minus pi by 2 to 0 again. So using these two, a plus b clearly belongs to minus pi to 0. Doing nothing but adding the lower limits as well as adding the upper limits. So if a plus b belongs to minus pi to 0, I know that you have already got it, that a plus b belongs to minus pi to minus pi by 2, which we have recently iterated again. Our fourth observation, clearly using our fourth observation. Alright, so I already know that a plus b belongs to minus pi to minus pi by 2. But I don't seem to like the negative signs much. So I would rather suggest, why not add pi to every number in the inequality so that the inequality does not change. So when you add in the lower limit pi, it goes 0. When you add in the upper limit pi, it goes plus pi by 2. And my a plus b plus pi is an angle of first quadrant then. Right, students? Perfect. So let us now come back to the basics from where we have started. What was tan of a plus b? Nothing but x plus y upon 1 minus xy. So, may I ask, what will be tan of a plus b plus pi? You will say exactly the same, x plus y upon 1 minus xy, right? Because tan of pi plus theta is equal to tan theta. So, here also I know that a plus b plus pi is an angle of first quadrant. So, I can directly take tan inverse here. Perfect. So, when I am going to take tan inverse, this is going to be a plus b plus pi is equal to tan inverse x plus y upon 1 minus xy, which makes my a plus b equals to exactly what I needed to prove. Let us now comfortably replace our a as tan inverse x and our b as tan inverse y. Hence, our proof is right in front of us, which clearly tells us that tan inverse x plus tan inverse y is nothing but minus pi plus tan inverse x plus y upon 1 minus xy. So, to sum it up, what did we do? We first analyzed that a plus b should be an angle of first or third quadrant. Then we separately analyzed a and b, and then again we came to the conclusion that a plus b is actually the angle of the third quadrant. And from there was no looking back, and we could directly add pi, and we were knowing that that particular angle is the angle of first quadrant. Hence a plus b is minus pi plus tan inverse x plus y upon 1 minus xy, and hence our proof. So in the next lecture, students, we are actually going to solve a lot of problems based on this proof. See you soon.